Hi everyone. In this video, I'm going over Chapter 11 from the CCNA Routing and Switching Study Guide written by Todd Lamel. These will be the hands-on activities or the hands-on labs at the end of the chapter. Chapter 11 was all about VLANs, configuring VLANs, access ports, trunk ports, and Inter-VLAN routing. So naturally these labs will all be focused around VLANs and Inter-VLAN routing. There is a topology depicted at the beginning of the hands-on labs that looks pretty similar to this. I did substitute in a layer 3 switch here rather than a layer 2 switch. So if you need to, go ahead and pause the video for a couple minutes and build this topology. Alright, once you have this built, we have S1 is connected through ports 15 and 16 to S3 on ports 1 and 2. And then 17 and 18 here are connected to ports 1 and 2 on this switch. And the switches are connected down here together on ports 5 and 6. The PCs are on ports 3 and 4, respectively 3 and 4. And the router is connected on port 8. Alright, so once you have that all cabled up, I do know that in the topology it shows a layer 2 switch here, but the last activity, 11.4, revolves around using a layer 3 switch, or a multi-layer switch here. So I'm just going to start with it, so I don't have to configure a layer 2 switch, swap it, and then reconfigure the whole thing. I'm just going to start with a layer 3 switch. Alright, so to begin, 11.1, we're just going to configure and verify VLANs. Really all we're doing is creating the VLANs. So we just need to give the command VLAN 10 and VLAN 20 on each switch. Alright, and then once you've done that, it does want you to verify with the show VLAN. Let me go ahead and make this a little bit wider. And taller. Alright, so here's my command, show VLAN. We can see the default VLAN 1 is always enabled by default with all of the ports assigned to it. We now have VLANs 10 and 20 created with a default name. So we didn't customize the name or specify a specific name for those. If you're in a real production environment, this might be the department that you're going to use that VLAN for, like marketing or sales. It could be a geographical location, West Wing, something like that. We also get a whole bunch of additional information down here. And so the alternative to that command is show VLAN brief, which is just going to show us this top portion, basically this table. So we should see the exact same thing down here. It's just that table. Note these bottom three show as active, whereas on the regular show VLAN, it shows active unsupported. Sorry, bottom 4 there. So that's the slight difference there, and then the other difference with the VLAN brief is that we don't get these extra tables with information that may or may not be particularly useful unless you want to verify like an MTU. In any case, we can see that they've been created. So then in lab 11.2, we're going to configure and verify our trunk links. So again, we'll start on switch 1. And we had ports 15, 16, 17, and 18 that are all going to be trunk links, and actually port 8 here will also be a trunk link. So we can do an interface range 15 through 18 and 8. Alright, and the first command we want to give is switchport trunk encapsulation. I want to set it to .1Q. and then give the command switchport mode trunk. And we get all of them go down, get reconfigured, and come back online pretty rapidly as a trunk link now, rather than an access link. So there's our commands again. And so the reason we do that is because an access link can only carry data from the same VLAN that it's a part of. So if I set up an access link for VLAN 10, it can only carry data for VLAN 10, which is good because it'll help reduce our broadcast domains. But between switches, I need to be able to transfer data for multiple VLANs, and that's exactly what a trunk line does. Is a trunk line is kind of seen as a member of multiple VLANs, so it can transmit for any assigned or any authorized VLANs over a trunk link rather than just a single VLAN. So that's pretty important to know the difference between an access and a trunk. Alright, so we want to go ahead and do the same thing for our other two switches. Just configure them for trunking on these 4 ports. I need to double check 1 and 2 and 5 and 6. So we'll go ahead and do another interface range. And 5 and 6. And note on this layer 2 switch, if we try to give the command switchport trunk encapsulation, it doesn't recognize it. You only have 2 options for encapsulation. The first one is a little bit older. It is called Inter-Switch Link, ISL. It was proprietary to Cisco hardware, and it functioned very similarly in that it would allow multiple VLAN traffic across a single port, but because it was proprietary to Cisco, other hardware manufacturers didn't support it, and so we ended up transitioning into IEEE 802.1q as the more common method of frame tagging for VLANs. And instead of actually encapsulating an entire frame, it just inserts a field into the frame to identify the VLAN. So if you're using a Cisco network that has some non-Cisco components, you have to use 802.1q. If you're entirely Cisco and you're somewhat older hardware, then you can do ISL. But even Cisco is moving away from ISL and just making the standard 802.1q. So these switches that I have, my layer 2 switches, they don't even have ISL on these anymore. It's just the 802.1q. Which is why it no longer recognizes the command, is because there's no other option for these switches. So instead of giving the encapsulation command, we just need to tell it to be a trunk port. And they should go down and come right back up. And we see that 8 did not go down, and 1 and 2 have not gone down. So 1 and 2 are not configured on the other switch yet. I guess 8 would be up here. And 8 did not go down and come back up, reconfigured as a trunk port, because the line is disabled from the router. So it sees that line is down completely right now. Anyway, so we've configured switch 2 for trunking. We need to configure switch 3 for trunking. Five and 6. Alright, and it looks like STP is automatically enabled. So spanning tree protocol to prevent like loopback storms or broadcast storms. STP is designed to prevent that. And so we have one link that's actually active with backup links as needed across the network. And so that helps to prevent those broadcast storms. I'm not going to cover a whole lot of in-depth material on STP. If you're wondering about that, you might have to do some additional research. But STP is very important when you are using redundant links like this. Multiple links to the same sources. Alright, so we now have our ports configured for trunking. And lost my place here in the book. There we go. So we can verify our trunk links. We can pick a random switch here. Go ahead and come back out, and we'll give the command show interface trunk. So make that a little bit bigger so we can see everything here. So I have ports 1, 2, 5, and 6, which are my switch-to-switch ports. By default, the only option that was available anymore on these switches is the 802.1q encapsulation, which is where it adds that VLAN tag information into the header of the frame. It shows that they're trunking. Their native VLAN is the default 1. It allows 1 through 1005 for those VLANs across those ports, so it currently allows everything. And it currently has 3 active VLANs. 1, which is the default, and then 10 and 20, which we just created a couple minutes ago. Another command that we can give, we want to look at a specific port to see how that trunking is configured, to see what kind of configuration it's using for that trunk link. We can give the command show interface and then actually specify an interface like F15 or F5 in this case, and then Switchport. And so it gives quite a bit of information. There's my command. So it verifies this is for this interface. It is enabled as a trunk mode with .1q encapsulation. Again, it's the only thing available on this switch. The access mode is currently VLAN 1 as the default. The native VLAN is 1 as default. Alright, so you can kind of use that to help verify your trunking. If you end up having a native mismatch between switches, it will display an error stating that there's a native VLAN mismatch, and that's a good way to double check and see what the native is here, compare it to the other switch. If they have different native VLANs, then they'll oftentimes have problems and throw that error where they can't process data between different VLANs if it's not tagged. Anything that's not tagged is automatically assumed to be part of the native VLAN. So if my native VLANs are different and a device connects that's untagged, then one switch will see it in one VLAN, the other switch will see it in a different VLAN, and so they won't be able to properly handle the data flow for that device. Alright, so it looks like that covers pretty much everything for 11.2. We're moving into 11.3, which is configuring the router on a stick for routing. So now we're actually going to jump up into our router. And before I go too far in configuring this, I'm going to go ahead and run a little bit of network traffic. Right, so we have no ports. So there's one extra thing that the book doesn't mention that we'll need to do is either assign static IP addresses, or, because I think it would be kind of cool, I'm going to set up a DHCP server. You could set up DHCP through your router, but for the last step here, we're actually going to be disabling the router. So I would rather have a local server with DHCP configured on it. So the first thing we want to do, since we have multiple VLANs, I'm going to go ahead and give this server 2 interfaces. That way I can connect it to each VLAN directly. Fast forward time so that thing boots. And then I'm going to enable DHCP here. And so one of these is going to be the 10.10.10.0 network. So it's going to be 10.10.10.1 is how I'll configure the gateway. I'll configure the server with a static address of 4. And I'll start assigning DHCP addresses at 25. Alright, so we see the basic configuration there. And so that's for G1, G0. I'll do the same thing for VLAN 20. Alright, then I do need to go ahead and start giving static addresses to my server, which is a good practice anyways. Tell it to use itself as a DNS server. And then G01 will be in VLAN 10. Alright, next I want to go ahead and get it cabled. So 01 is VLAN 10. I'll go ahead and put it on port 7 there. And 0 was VLAN 20, again on port 7. And I'm going to go ahead and configure port 7. Actually, let's go ahead and do a range. 3, 4, and 7 as access ports. And so on switch 3, I'm going to go ahead and assign those ports to VLAN 10. We'll do the same thing on switch 2, but assign them to VLAN 20. So that way I know that my VLANs are configured for specific interfaces now as well. Give those a moment to configure and become established. And now I should be able to get a DHCP address from my server, because this doesn't require any routing. They're directly connected on the switch. Alright, so I'm getting a DHCP error. Let's come verify that DHCP is on. Alright, let's try it again. There we go. Although it's not starting the correct range there. Bring that back up to 25. And bring that back up to 25. There we go. And again, this is just an alternative to static setting addresses. But these devices, these computers, are going to need an IP address in order to communicate over the network. Alright, so we have addresses everywhere here now, well, on our user end at least. So next thing we want to do is make it so that our VLAN 10 can communicate with VLAN 20. Currently, we can, as long as we're within the same VLAN, we can communicate. So we have success pinging across. We have communication locally, but if we try to cross VLANs, we have no way of routing between our VLANs right now. So the first way I'm going to show is going to be through the router, which is R1 in this case. And so there's a few things that we're going to do. The first, we are going to go into our gigabit Ethernet port, which is the one connected directly to the multi-layer switch. And we're going to assign it a management IP address, and that's for the entire port itself. So it'll be IP address 172.16.10.1, for example. Alright, and then we want to go into our sub-interfaces, because router on a stick uses one physical interface and creates multiple logical interfaces. So we're going to go ahead and configure those logical interfaces now. So for example, subinterface 10 is going to be for VLAN 10. So I need to configure it for encapsulation, again as .1q and VLAN 10. And the next thing I need to do is give it an IP address so that my VLANs can use this router as a gateway. Alright, so that takes care of VLAN 10. Next I need to configure for VLAN 20. So I'll create a subinterface 20. Again, give it the encapsulation .1q for VLAN 20, and then assign an IP address. That my VLAN can use as a gateway on my VLAN devices. And then I'm going to come back to the physical interface and give it the no shutdown command. And that should bring all of my sub-interfaces online as well. Alright, I'm going to go ahead and fast forward, let it build and configure, and we should be ready to start doing a little bit of communicating across the network. Remember, the easy or simple PDU is like a single ping, so it's quite often that will fail the first time, even if you came in and did an actual ping. For example, we'll go ahead and ping from PC2 to PC0. There's been no network traffic in Packet Tracer from these two devices yet, other than getting a DHCP address. So we'll go ahead and run an actual ping over to 10, 10, 10, 26. No, let's go 25, I think was PC0. 25. And even doing a command prompt ping, which sends 4 echo requests, even then the first one will still time out in Packet Tracer because it's updating the ARP table with that first echo request. And then the other 3 are successful, so we're good there. So that has actually enabled our Inter-VLAN routing. So these two VLANs can communicate. If we want, we can switch over to the simulation mode here. And we can actually watch that traffic travel through the network. And we'll see how it uses the router as a router on a stick for Inter-VLAN routing. So the PC sends the echo request, goes to the local switch. Because of STP, these lines they're pseudo-disabled. The switches know that these lines exist, but they're held more as a backup. So they're not going to be active. So the packet is going to come over to our other switch based on how our spanning tree protocol configured within our network. So with spanning tree protocol, it comes over to the other switch, goes up to our multi-layer switch, and then goes to the gateway for VLAN 20. The router receives it, and then routes it over to VLAN 10, and sends it back down to VLAN 10. So that whole process there, PC on VLAN 20 sent an echo request. It was routed through the network, back down to VLAN 10, and has now been received, and then the PC in VLAN 10 will need to reply, and so we'll see that follow the same path back. And we're successful. So that's how a router on a stick works, is that the VLAN will use it as a gateway, and the router itself will just send it back down with the appropriate VLAN tag to come back down to the correct PC. Alright, so that looks like most of 11.3. There is one step there, pinging from a PC on one of our VLANs to the router subinterface configured to be the gateway. I skipped it, but we know it works, otherwise we wouldn't have Inter-VLAN routing. If you wanted to go ahead and test it, you can go ahead and run a command prompt ping. And that way you know you're addressing the correct subinterface. Alright, so it looks like that's everything for 11.3. Moving forward into 11.4, we're going to configure Inter-VLAN routing with a layer 3 switch, or a multi-layer switch now. So we're going to disable the router, and that's going to be the first thing we do, and we're going to use S1 to provide this Inter-VLAN routing without actually using a physical router. So let's go ahead and disconnect that. Verify that we no longer have connectivity between our VLANs, no routing happening between them. And now we're going to configure this multi-layer switch to handle that routing between VLANs. So make this a little bit larger. Alright, so the first command that we need to give is IP routing. And that tells this the layer 3 switch that it's going to be handling some basic routing protocols. This command won't work on a layer 2 switch. We can come and try it, but it just doesn't recognize the command. It doesn't have the capability of handling any kind of routing protocols. Alright, so back in our multi-layer switch, we then need to create the VLAN interfaces here rather than on our router. So we're going to create VLAN 10's interface and assign an IP address that will be seen as the gateway by our end devices, which was already configured once as 10.10.10.1 as a /24. And then we're going to go ahead and configure another interface, create another interface for VLAN 20, and assign it the gateway address. Next, we want to go ahead and clear our ARP cache, our ARP tables. So that way, our multi-layer switch won't try to send VLAN communications to the router for routing, because it had already built that ARP. So now it will have to rebuild with new traffic coming through. Anytime traffic comes through, it'll have to rebuild its ARP table or our ARP cache. So let's go ahead and try to ping up. There we go. So it's rebuilding that ARP cache now, which requires a little bit of network traffic. Alright, there we go. Alright, the next thing that we should be able to do is ping from one VLAN to the other to show that we have connectivity between our two VLANs. So in real time, instantly successful, and now we can verify in simulation mode to see how exactly that packet will be handled on the network. So we go ahead, and it looks just like it did before. It goes from one switch to the next, and then up to our multi-layer switch. And now our multi-layer switch is handling the routing protocols, which is then routing it over to the other VLAN. And then it'll follow the same path back. So the only difference here is that we're using a multi-layer switch to handle it rather than an actual router. Whether or not you choose to do that in your environment depends on your network. But know that that option is available. Alright, and I think that covers everything from the hands-on labs in Chapter 11 here. So again, we covered a lot of VLAN configurations, the differences between access ports and trunking ports, or access links and trunk links specifically. We handled router on a stick, using a single router interface to route between multiple VLANs. And then we handled multi-layer switch routing protocols. As always, if you have any questions or comments, please feel free to leave them for me below, and I will try to reply in a timely fashion. Thank you so much for watching, and I hope to see you in my next video.